Welcome to the Raytheon Technologies Girl Day sessions. I'm Adriana Johnson, and I work for the Collins Aerospace Corporate Social Responsibility team. Today, we're going to talk about the spacesuit, and I have Jen Maddie from the Collins Aerospace Spacesuit Division to talk about it. But before we jump over to Jen, we're going to watch a quick video on what the spacesuit looks like. Now that we're excited that we saw the spacesuit, I'm really excited to introduce Jen Maddie from our spacesuit team. Jen, can you tell us a little bit about yourself?
Yeah, hi, I'm Jen Maddie, and I'm a value stream leader at Collins Aerospace. And I work with the spacesuit team with the EMU, which is used on station, and the XEMU, which is for our exploration to the moon and Mars.
And for those of us who don't know what an EMU is, what does that acronym mean and what is it?
Well, the EMU is the Extravehicular Mobility Unit. So a long name to mean spacesuit, and this particular one is used on station. It's the big white one that you might have seen in pictures. It has a big white backpack on it, and they use it to go outside space station and fix things that need to be fixed or installed on the space station.
So Jen, tell us a little bit about the spacesuit. Why does an astronaut need to wear it, and what is it protecting the astronaut from in space?
Well, there's the vacuum of space, which if we didn't have that, we wouldn't be able to breathe. So obviously you need protection to create like a little atmospheric bubble around you to protect you. It's very hot and very cold out there. It swings from positive 250 degrees to negative 250 degrees. And those are some huge temperature swings. The spacesuit is designed to protect you from that. We have cooling garments inside that also keep you comfortable for when it's really hot or when you're working really hard, generating your own heat. We also make it so you need to see your workspace and what you're doing. The helmet provides various layers in its visors and sun visors.
Seen in a lot of movies that it's pretty harsh out in space. Can you talk through a little bit about some of like radiation or sun issues and how the spacesuit protects our astronauts?
Right. It has layers to help protect us from the radiation embedded throughout the whole suit garment that you wear. And it also has a sun shield. So when you're working in the sun, regularly you'll be working and you'll be in a shaded region and you flip your sun visor up so you can see better. But then whenever you're in a sunny part of the station, you need to flip that down, just like on a bright sunny day when you go to the beach and you have reflection from the water, the sand, the sun's baking down on you really bright. Same thing in space. When you're on the sunny side, it gets very warm and unforgiving. So you need that extra layer of protection in your visor and throughout your body there.
So Jen, what are the different components of the EMU or the spacesuit? How does it keep our astronauts safe?
Well, there are several components of the spacesuit. When you start getting dressed to go outside to perform your work, you would put on an LCVG over your long underwear. And what that does is it keeps you nice and cold. It's kind of like climate control for your body. It has little tubes that run all the way through it, zigzagging up and down, that run cool water to keep you cold. Next, you would typically pull on your pants. The shoes are included, and then you would don the hard upper torso, which you usually see them kind of dive into if you ever watch them perform an EVA or getting ready for an EVA on television. After that, you would be putting on your gloves. You usually have some friends on the space station that will help you perform some of these operations. So you put on your gloves, there's special inner gloves, outer gloves, and then you put on your helmet. And once you put on your helmet and button it down, you really need the most important component. It's the backpack. It has everything that you need to survive in space. Like I said, we've got water routing through to keep you cold. It's got big bottles for air for you to breathe and the systems that help clean the air as it comes back to you. It also has a display and control module right here at the chest that allows the astronaut to see what's going on with the suit to make sure everything is okay. It can give them warnings and general status of how they're doing. Before you put your helmet on, you wear what they call a Snoopy cap. It's a white hat with black earmuffs, if you will, and a microphone that comes down so you can hear and talk to your other crew members and your ground team to help you along your way. There's other ancillary equipment such as helmet lights, cameras, everything you need to do your job, tool caddies, different things that you can attach to your suit to help you perform your work.
Holy cow, that is a lot of pieces. Does Collins Aerospace make all of them?
They mostly make the backpack and the hard upper torso and the electronics display. We have several partners that we work with to provide a lot of the soft goods, such as the gloves and the pants, the boots, the knees, the elbows, all of those components. And there's a lot of team members. We're a big contract that goes across several companies that we all combine together and work with NASA to make the suit and operate the suit on station now.
So, that sounds like a lot. Like, how much does a spacesuit weigh?
Well, a spacesuit weighs quite a bit. It weighs around 300 pounds, so it's very, very heavy. If you've even tried to lift 50 pounds in your everyday life, you know that is quite a bit. So this suit is really designed to be operated in space where you're weightless, so you don't feel any of it. We don't typically wear a full lifelike spacesuit without aids on the ground. During training operations, they usually train in a pool. We have a very, very large pool here called the NBL, the Neutral Buoyancy Laboratory. It's gigantic. They have a whole mock-up of the space station inside the pool. So the astronauts learn how to do their jobs by swimming, basically, floating around in the pool. Technicians there allow them to kind of balance it out so it feels just like they're in space as they're practicing to do their job. Otherwise, in space, it feels rather weightless. However, you do have to have some strength to make the suit move, especially your gloves that you use for transversing around the space station and using the tools that you need to do your job.
So you mentioned these tools. What are these astronauts using these tools for? What are some of the common actions that they're doing in space?
Well, they mostly use them to put stuff together. They put together the whole space station. They largely install new pieces of hardware as they come up to station. They also do repairs on broken or troublesome pieces of hardware that are up there. They have special tools that they use to accomplish these tasks that have been specially designed to work with their gloves. Their gloves are much larger. Think of like a winter glove that you would use for skiing, and how difficult it might be to open and close your hand and how bulky it would be around your fingers. The astronaut gloves are very similar to that, and then it could be difficult and kind of cumbersome because they're much larger than your own fingers to use. So special tools have been designed to work with these various pieces of equipment that come up to be installed on the space station. So every tool is made to work in space and with the astronaut in mind.
So that sounds like they're in their spacesuit for quite a while. If they're building stations and fixing stations, what's the longest that an astronaut can be in the spacesuit?
Well, typically an EVA is between 5 and 8 hours, usually somewhere right around the middle. However, they can be in their spacesuits for much longer because we also have to count for the time that they're getting ready to go out the door and to come back in. There's a lot that goes into the checkout and pressurization to get them out the door. It'd be like being in your own little bubble for most of your working day.
So if their astronauts are in the spacesuit for a large portion of the day, I mean, I need to use the restroom a couple times a day or like drink some water. How does Collins solve those problems for our astronauts?
Those are really common problems. If you're going to be in the suit for the better part of a day, you're going to get thirsty and have to go to the bathroom. So what they have inside the EMU is they have a special drink bag. It's very similar to a camelback that you might be using for hiking or something like that, where it has a kind of flexible plastic reservoir and a straw that comes kind of right down near your mouth. And so what they do is they're able to move their head into position to drink water anytime that they want during their EVA. However, on the other side, when you need to go to the bathroom, it's actually a very simple solution. They have a fancy name. It's called a MAG. It's a maximum absorbency garment. But really what it is a great big diaper, similar to an adult diaper. We want our astronauts very hydrated so they can stay on task and focus on their work and not have to focus on whether they're thirsty or need to go to the bathroom. Because as you know, that can present a problem of getting the work done when we really need them to be out there.
How does Collins know to design it in this way? Like, did you go into space? Like, how do you know to do like little holes in the helmet and all of that?
Well, we've been learning for a really long time. There were several suits ahead of the EMU. We had the Apollo suits that actually landed on the moon. There were the Gemini suits that, did some of the first spacewalks, which were just hanging outside their vehicle where they weren't really doing a whole lot of work. The EMU that we have now is doing a lot of work building a space station. So it doesn't have a whole lot of leg mobility, and it has a whole lot of upper arm mobility to transverse with your arms and put things together with your hands. So a lot of the focus on the tools and the suit really went into optimizing the suit so it can work in that microgravity situation as opposed to walking around on the surface of the moon.
Gotcha. And so do you have astronauts on staff that help you talk through this and think of solutions to some of these problems?
Well, we work directly with NASA, and all the astronauts work for NASA, at least in the US. We have international partners on the space station, so occasionally we do work with some of the international partner astronauts. We work with them regularly in their training, get feedback when we introduce new hardware. We do also have a small number of retired astronauts on staff at Collins to help us with some of our design questions and implementation that we can pull on. So we really pull from a wide array of people in order to solve some of these very difficult problems.
So let's switch gears and talk about actually constructing a spacesuit. What kind of engineers are needed to make the Collins Aerospace spacesuit?
That's a really good question. There are all kinds of engineers. We pretty much have people collected from all reaches of engineering. I myself, I'm an industrial engineer, although I do probably completely different things than a typical industrial engineer might do when they get out of school. So depending on what kind of engineering you are or what your interests are, there are a number of different jobs and specialties that you can be. A lot of them are mechanical engineers. But we also have a lot of materials engineers, safety engineers, all sorts of things, in systems engineers, even people who aren't quite in an engineering field, but a technical field or management field are great contributors to making our suit work. So there's a place for just about everyone to contribute because there's so many different systems that we rely on, from the artistry of the soft goods to the very technical and structural nature of the PLIS backpack that provides you all the support that you need to stay alive. So there's really something for everyone there.
Oh my gosh, that sounds like a lot of very important systems. And these are up in space where there's things flying at you from all angles. What happens if a system fails or you get hit by an object like a meteoroid?
Yeah, there are redundant systems on our spacesuit to help alleviate some of the problems that you might have if you have some sort of accident while you're up there. For a lot of the failures, we have a backup oxygen system that kind of kicks in by itself. It doesn't need any power in order to operate. It provides breathing air for up to 30 minutes And this is really important because it can really contain a lot of different kinds of failures, like a micrometeoroid if it hits your suit. Although there are many, many layers, protective layers on the suit, it could eventually come down so far as to break the bubble, essentially, the bladder of the suit where you have air leaking outside of the suit. At that point, the secondary oxygen tank would kick on and add supplemental air in order for you to be able to make it back into the station safely before you run out of air. There's other situations on station that are actually caused by micrometeoroids and stuff flying around in space. Is when it hits stations, it creates kind of almost like a little mini crater on some of the handrails or other parts of the station. Now, most of the time it doesn't really hurt the station. It just creates a rough patch essentially, but it can cut our very sensitive gloves because you use your gloves to move yourself around on the space station the majority of the time. So you can have a cut on your glove, which can be a very serious incident, but that backup system would allow you to get back to the hatch safely.
So it sounds like you need to move quick. If you have like a cut in your glove, how fast does the spacesuit go and how does it propel itself?
Well, it's a very slow operation. You largely traverse the space station by using your hands. Hand over hand, you have tethers that you need to attach at certain points so you don't fly off vehicle. But most of your movement is done by your hands instead of your legs, like we're used to walking around here on Earth. There's also another way that you can get around, and that's using the robotic arm. We have a special stand that our boots clip into that allow us to safely perch ourselves on the robotic arm so they can move us very long distances quickly with the robotic arm with your friend inside controlling that, kind of like a video game, to move you to another section of the station pretty quickly.
That is amazing. I want my own robotic arm and my own spacesuit, but who does Collins sell their spacesuit to?
Well, right now we sell our spacesuits to the government, so NASA. That's where all of the astronauts are, and who our main provider is NASA at this time.
So what is Collins doing to help space travel in the future? Like, can you talk through next gen spacesuits or what your guys are thinking in your team?
Yeah, sure. And NASA is actually developing a next generation spacesuit. They call it the XEMU or Exploration EMU. Collins provides some very critical parts that are going to go in that backpack to help them breathe and do everything that they need to do. We're kind of like the heart of that backpack that provides the life support. So we're very happy to be providing some of those very critical parts.
So Jen, this is pretty exciting stuff. If I were a young girl and I want to come work at Collins and work on a spacesuit, what would I do? Like, what would be my next steps? And what kind of degree should I be looking into or engineering disciplines?
That's a great question. Really, we have a lot of different people supporting our program. Most of them are engineers, but we do have business and chemists and all sorts of people working on our team. If I were you, I'd probably recommend, some kind of technical degree, like an engineering degree. A lot of them work with what we do. Mechanical engineering is really popular. I'm an industrial engineer, but there's a lot of routes to go in depending on what kind of work interests you. So I would definitely plan on receiving some kind of technical degree. Usually it's required for our work here at Collins and on the spacesuit team. So that's a really great place to start, but stick with what you're interested in. I think you'll make them both the best contributions in what your passion is.
Well, this has been so informative, Jen. Thank you so much for taking the time to talk to us about the spacesuit and what Collins is doing. I'm so excited to keep up with it, and I hope this was very informative to you, the students, and hopefully we get to see you working with us on a spacesuit soon.
Thanks for having me. I'm so happy you asked me here for Girls' Day 2021. I hope you girls are inspired and go off and do great things.